everyone, welcome to the third lecture on fundamentals of C++ programming. I am Murtaza. In the last two lectures, we had Q&A session as well as we had assignments and examples beside exploring the concepts. In lecture 3, we are going to talk about variable initializations, expressions, and statements. I hope you have done the exercises and the assignments, and if you have still any questions about lecture 1 and 2, you can write me directly or in the comments, and I will try to answer your questions in the next session. Okay, let's get to the lecture. In the previous sections, we talked about machine code, talked about compiling versus scripting languages, their difference, and C++ is a compiling language. We talked about building blocks of C++ and compared it with language such as English. And we also talked about compiling and linking, compiler error and linker errors. We talked about one definition rule, declarations, how we declare variables, functions in classes, as well as declaration identifiers built in data types. In this lecture, we talk about how we initialize variables when we declare them. How do we make expressions, which is combination of operands and operators. We will talk about selection statements or conditional statements and iteration statements or loop statements. We will provide example, and at the end, I will give you an assignment. Initialization is optional in C++ programming, though it is recommended to initialize some variables at the very beginning. There are two methods to initialize variables. One method is the safe method, which yields a compiler error warning if implicit conversion potentially results to loss of information. Variable name, brackets, expression, for example, double ice density, and brackets 0.91 is initialized. So the density of ice is initialized with a value of 0.91. This is a safe method because when we compile, the compiler gives us an error or a warning that this is not true, it's not correct, or you may lose some information. In the unsafe method, which also implicit conversion occurs, variable name equals to an expression or variable name parentheses expression inside. For example, if we have integer, the cat population equals to 1,200, this is an unsafe method. And integer population 1,200, we have declared variables in a method where in case we have implicit conversion of data types, we may encounter loss of information. Initializations can be complicated. For example, if we want to initialize the volume of a cylinder, we cannot do it directly and easily. First, we need to initialize the pi, double pi with the value radius with the value, for example, 2.75 in the height of cylinder. Then we are able to initialize the volume of the cylinder with pi square times square of radius and height times height. So this is a more complicated way of initialization of a volume of cylinder. For example, here you see we have double pi equals to its volume, and if we have an unsigned initialization and unsigned b equals to pi, which is, of course, an ANSYS way, the compiler will compile it, but b will be equal to 3, and the rest of the value of pi after the decimal point is lost. However, if we initialize in a safe method, for example, unsigned b in brackets pi, then the compiler will not compile, and it will give us an error with the potential information loss or similar message. Okay, let's get to statements. We have mainly two types of statements. One is conditional or if statement, and another is iteration statements that we will talk soon. The conditional statement or if statement executes multiple codes based on conditions. For example, if you see on the right side, the structure is that first we write the keyword if. Inside the parentheses, we give condition. And the condition, whenever it is met, whenever the condition is fulfilled, then the code block inside the brackets will be executed. We may have multiple else if condition, many conditions if we have, and it's optional. So there might be 3, 4, it depends on the conditions, else if. And then we may have the keyword else, which is also optional. And after that, we may have a code block inside a bracket. Each bracket is a block of code and may consist of multiple statements. A variable defined inside a bracket is only visible inside, and it will not be accessible or visible outside the brackets. In iteration statements, we may have while loop statements, we may have for loop statements. In while loop statements, the code will execute if until the condition is fulfilled. For example, if we say while, for example, a is smaller than 100, then the code, for example, will calculate the square root of the number. So the code will iterate over and over again, and until the condition is satisfied and fully fulfilled. We may also have do while loop do while statements, and it will execute the code at least once in the beginning. We may also have loop statements of kind for. As you see in the right side, the structure is that after writing the keyword for, inside the parentheses, we have three parts. First, we initialize the value and give the condition, and then increment or decrement after that. We can have a combination of if statements and for statements, and you also may have jump statements, for example, continue and break. And in many cases, jump statements can be avoided if we may have multiple loop conditions or statements. Okay, let's go to the expressions. An expression is a sequence of operators and operands that is specify a computation. So expressions are very fundamental and very important in C++ because we may have many arithmetic as well as assignment, logical, comparison, member access, and arithmetic expressions and operators. Okay, let's see the difference between the operators and the operands. If we have an example here, for example, a plus b equals to 0, here a and b are the operands, where the operators are plus and equal. Operators with one or two operands are called unary or binary operators. So in a statement, we may have many operators and operands, and the way the computer or the C++ performs the calculation is based on the precedence. For example, if we have a code std out a plus b std in line, here first a plus b will be calculated, and then the results will be displayed in the console. If we have, for example, a plus b divided by 3, first inside the parentheses, a plus b will be calculated, then the result of this will be divided by 3. We also need to understand that the expressions can be nested. For example, we may have 2 or 3 parentheses inside a parenthesis. And a plus b, for example, here is a sub-expression. And a, b, 3 are called primary expressions because they cannot be divided further. And when operators have the same precedence, their associative activity will determine the order of evaluation from left to right, for example. Okay, let's go to examples. In expressions, we may have also different data types. For example, if we have integer divided by integer, the result will be integer. For example, if we have 1 divided by 4, 1 is integer, 4 is integer, the result is 0, because both numerators and the 1 and 4, of course, they are integers. That both denominator and numerator, they are integers. However, if we have integer divided by double, the result is double. So it's very important to understand in order to not make mistakes. And double divided by double results to double, as you see. So we also need to understand that we may have some keywords in C++, and sometimes when we declare variables, our variables would be better not to be the keywords such as double, integer, and not. They can't be declared. We can use and instead of the operator and or instead of this and this or we can use the word or and using the word not instead of exclamation marks. So let's go to examples. We have 5 examples, and then you need to do the exercises, the exercise for this lecture. I will ask you to send me your exercise, and if you have encountered any issues, you can send me a message. I'll try to answer your questions. Okay, let's go to example 1. This example, we try to use only the C++ file. However, you can divide the code into header files and C++ file, and then you can include the header files in C++ files. So here we only consider the C++ file. To start with, I need to include the history. I also include CMate because we may do some calculations, and I need to have a main function. And in the first example, we do initialize variables in a safe and unsafe way. For example, we may initialize integer a. In a safe way, we may have, for example, 10. And I need to, for example, I initialized variable a with a value of 10, variable b with in an unsafe way, I may initialize it with value of 5, and also b equals to c equals to 3. So in all of these cases, we have initialized the integers, but in different ways. The first one is initialized safely. However, the second and third, they are initialized in unsafe method. Well, let's do initialize some double as well. For example, and we initialize 5, for example, with value of 3.1415. Or we can, for example, highest density, but in an unsafe way, we may have 3.9, okay, 0.91, for example, or we have water density can be 1.0. So in these examples, we have initialized both data type, integer and double, that in unsafe and safe method. So A is initialized in a safe method. B and C are initialized in an unsafe way. The same is true with the table type. We can say that y is initialized. Y is initialized in a safe method. Ice density and water density are initialized in a safe way. The reason is that when we run the code is executed. However, when we, for example, use unsigned example P equals to A, and unsigned S equals to I. Then when we execute the code, we don't see any error because it's initialized in a safe method, both A and pi. Let's do std out is equals to is you see that now here is equals to 0. Ice density is not 0. Ice density is equal to 0.91. So here we have lost information without any errors, without receiving any error here. We can also initialize S in another way. When that was as an unsafe, and here we can write it in a safe method. And if we do so, then you see the code doesn't run because we have encountered an error. It says that conversion from double to unsigned integer requires a narrowing conversion. So this is the error that tells us that you may have information loss, and therefore it's more conservative and more safe. Or if we do it again in an unsafe way, then the code runs without any error. This was the example one, and explain how to make expressions, the difference between operands and operators, and how the precedence works. We had declared variables in the first example because they are in the same main function and they works inside the function and operate in expressions. Here we have example double m equals to y plus i's density. Here, i's density and pi, they are operands, and plus in equal sign, they are operators. So we can see m equals to m, and the results will be equal to 4.0515. And this is a very short expression. However, we may have, for example, double r equals to let's do an example with integer. Integer r equals to a plus b plus c. Run the code again, and it will run. If you want to see the result in the console, we again need to write code r equals to and r equals to a plus b plus c, and here I need to write r so that the value of r equals to r. So r equals to 18. So here they have the same precedence, a plus b plus c. However, a plus b, first it needs to be calculated, and then the results will be added with c. We may also have a constant number such as 1, and here first a plus b will be computed, then the result will be added with c, and finally with a. So the associativity rule will be implemented from left to right. So I hope you understand the expressions, operands, and operators. We have many kinds of operators, and I hope you understand the difference between, for example, the arithmetic operators, assignment operators, logical, and many others. In the example 3, we are going to talk example 3. In example 3, I will give you example about if statement using if, else if, and else. For example, if we have selection statement or if statement. For example, if we have the value of a, if should not misuse the words. We should use the words correctly, also particularly the operators. Here we can, when we run the code, as you will see, we have a value of a equals to 10, and here says that write a value for g. If we write, for example, 1, here says that g is smaller than a. So in the condition, and the condition is that 1 is not equal to 10. 1 is also not bigger than a or 10. And therefore, the building code block inside the else is executed, which says that g is smaller than a. Okay, this was example 3. Now we go to example. We will give you an example for the loop statements. Or about iteration or and while loops. An example, after running the code, you will see that the results would be like this. So the root of first member is 0, then root of 1 is 1, and the root of 2 is 1.41, 42, and the 3, and the fourth one is 2, and the 9, the root 9, the square root of 9 is 3. So the for loop iterates over an array or sets of numbers. Here it iterated from 0 to 10. So this is for loop. We can also have code for while. For example, okay, it is smaller than 5. Inside the brackets, we may have a building code, a block of code, for example, std cout a is smaller than 5. So this is a while loop, and for loop. This is example Okay, that's all for today. I will share the code with you. And in the next session, we will have a Q&A session where we can briefly discuss about all the topics we have covered so far. And if you have any questions about the examples in the lecture 3, you can write directly in the comment, or you can write me directly. If you like this tutorial, you can share it with your friends so that more colleagues and more students can join us, and we can make a more bigger community. Thank you so much, and I wish you best of luck and have a nice day.